Hey friends, welcome back to the channel. My name is Alex, and in today's video we're going to talk about deserializing JSON using Jackson and Spring Boot. Deserializing JSON is needed whenever we have to deal with a third-party API. And typically you use either the RestTemplate or the WebClient in Spring Boot to talk to these APIs. And then under the hood, assuming that you're using Jackson, the object mapper is pulling off all of the heavy work. So in this video, I'm going to show you how you can map JSON to data classes in Kotlin, how you can tweak the deserialization using annotations, and how you can take full control over the whole deserialization process. So with that said, let's code. Alright, so you can see I'm in the IDE. I have a typical Spring Boot application. So as usual, let's take a quick look at the build file. So there's nothing really important needed apart from Jackson. I have the Jackson module Kotlin in place. I also have the web flex starter here. It's not really needed, but I just keep it in. And for this whole session, I created some sample JSON, which looks like this. So you can see that the idea is that you're trading Bitcoin, for example. And this can be a response that you get from a trading platform, right? You have a wallet. It might have a name because you have multiple crypto tokens, for example, and there may be an array of trades, and every trade has an ID. It usually has a timestamp. It indicates whether this was buying or selling. Then there's the amount, there's a price, there may be a memo, which is optional, as you can see. And this is the whole model. This is what we're gonna map in this tutorial. So we're doing this test driven, so let me just close this. Let's go to the single test that's always created by Spring. So I just switched to the Jackson application tests here. And as you can see, I use the JSON test annotation. Usually what you will find here is this annotation, the Spring Boot test. And that really boots up the, no pun intended, the entire container, which is far more than we need for this test. So there are ways that we can slice the tests, and I'm using JSON test, which will make sure that I only have what I need to actually test JSON functionality, which at the very least is the object mapper. So let's use JSON test, and then let's start with creating our data class. I just drag in the sample over here so we have it handy. So let's actually start with mapping or using that example directly in the test before we go to the data class. So what I can do is I can use @value and then say class path sample JSON. So I want to inject the actual JSON into this test so I can use it. Wait init or that's a resource. So Spring should then just give me that resource to the sample JSON file that I have created here. We can then easily test this, but before that, let's also make sure that we have the object mapper, which we're going to need to map from the JSON to the data classes. So there we go. There's the object mapper. That should already work. Let's just, yeah, okay. Context loads, and now what we're going to do is use, let me think, string, files, read all bytes of the resource to file path. Oh, that didn't work out. I may make this a bit smaller. Resource file path. File, it's to path, isn't it? Like this, yeah. So that should give us the JSON as string value. And now let's actually go a bit further. The map file, we can use the object mapper and say mapper read value. Don't need this. Put in the JSON, and this is pretty much the simplest way or the most simple way to actually map the JSON to an object, because there's JSON node. It's not happy. Let me just think. Let's see, read values, is that correct? No, it's not values, it's value. Let's fix this. Yeah, so the JSON node is really just a direct mapping of what's going on here. So if we just use a print line of whatever we have mapped here. So let's just just run the test and see what happens. So, and as you can see, our JSON has been loaded as a resource, that's the first thing, and the mapper has successfully mapped this to an instance of a JSON node. So we could actually work with it here, but that's of course not very convenient. We want to use our own classes and instances of these classes, so this is what we're going to do next. So let's start mapping this using data classes. So the first thing that I can see that wallet is actually not the top level thing. You can see the outermost JSON object, that's this one, it has wallet as the first property, so I have to access that. And usually the way I go about doing this, and I hope there are better ways to achieve this, is using a data class, calling it wallet wrapper, and let's say wallet. We're going to create that in a second. So that's the outermost object that's going to be mapped. And then the next one is the data class wallet. We're going to create that. So a wallet has a name, it's a string, and it has a list of traits. And of course we don't have the traits yet either, so I'm going to go on, data class trait. Okay. And a trait has an ID, it has a timestamp string, it has the type, it has the amount, which is a string, as we can see right now, and there's a price, and I'm a big fan of using big decimal, so that should work out of the box, and there's a memo, I'll just put that in. So this is the hierarchy, so we have the wrapper and it accesses the wallet. So whenever we go one object level deeper, I'm providing a dedicated data class here. So now I can switch this, and instead of the JSON node, I'm going to use the wallet wrapper. And let's see if that prints anything good at all. So there's an error, as you can see, it failed, it's missing something. Yeah, the memo, of course, because as I've said before, the memo is optional because it's in the first trait, but it's not in the second one, so we have to make sure that memo is optional here. And now if I just run the application again, everything works perfectly. Good. So far we have mapped this JSON to our classes, but it's not very convenient, right? Because at this point you can see, apart from the price, everything else is a string. And I don't want these things to be strings. So I don't want the timestamp to be a string, and I also don't want the amount to be a string. And as you can see, what I've done here, and this is not uncommon to see in APIs, is that there's the amount, which is the decimal, including the ticker symbol, which is BTC. So what I want to do is get rid of the BTC symbol and just really access the amount of the BTC. So let's first start with the timestamp. What I want this to be is actually not a string, but local date time, because I have the date and I have the time. So if I just start to test again, let's see what happens. So JSON is unable to actually map from the string over here to a local date time. So we have to provide it with some more details so it knows how to do this. And there's the first annotation that we're going to use, which is called JSON format shape equals JSON format shape. That's a string. And now we can provide a pattern. And the pattern is actually the date format pattern. So it's the year, it's the month, it's the date, and it's the hour, the minutes, and the seconds. So this is a hint to JSON already how to take the timestamp and map this to a local date time. And as you can see right now, that works quite well. So if I just scroll over here, I can see it's a local date time. You might have to adjust it according to time zone and whatnot, but this can all easily be done with everything that I show in the next minute. Now, next, let's tackle the actual amount. And before we start with that, I'm creating an extension function. So extension functions actually allow you to add functionality to existing classes. It's not really that way. It looks that way in Kotlin, but under the hood, it's using static methods on the JVM. But what I can do here is as big decimal, because I want to convert from a string to a big decimal. And there is a similar function already, which is called to big decimal to big decimal, but that only works if the string already is clean. It doesn't carry the BTC that I have here. So what I have to do is actually take the string and then invoke split. So I'm splitting it into an array. I take the first element, which is really just the monetary value, and then I can invoke to big decimal. So that's just a nice helper which we're going to need for the next examples. So now I can just invoke on a string that only like a string that looks like this. I can invoke as big decimal, and it will just give me a big decimal out of the amount. All right, so how do we actually convert from the string to a big decimal as we want to do here? So I'm changing this already. It will not work out of the box, so I'm not running the application here, but what we need is a converter. So let's call this BTC amount converter, standard converter, and it takes a string and it gives us a big decimal. So let me just close this again a little bit more because we should know now what this looks like. And there's just one function that I have to implement, which is the convert function. So whenever we are given a string that might look like this, we have to turn it into a big decimal. So what we're going to do is, if value is not null, we return value, and now using the extension function as big decimal. If the value is null, I'm going to throw an exception. You don't have to do this. Usually, let me just finish it. Must not be null. You could also go with null values here if that's an option, but I'm usually in favor of using illegal argument exceptions whenever there's something that I did not expect to catch these things early on. So this is the converter, and now the final piece that we have to do is we have to register it on the amount. So we use the annotation JsonDSerialize, and then converter, and we just reference our converter like this. Yeah, so if I now run the application, then that should again work. Let's see. So we can see wallet, BTC wallet, and there's a trade, and it has the amount. And that's just the amount without the BTC. It's really the big decimal that I want. So now I can use that to calculate other values based on that. So what we've really done here is we changed the amount from string to big decimal, and now we have to tell JSON how to actually do the conversion. So we write our own converter to hook into the conversion mechanism, and then we just annotate the property with JsonDSerialize so JSON knows which property to use with that converter. And that's really all there is to mapping JSON. Now let's take it a step further and see how we can provide custom mappings. So let me just scroll down, and then we continue down here with a new class that's going to call new wallet. And I'm really just interested in the amount of BTC that I own. You can see that there's a trade for buying Bitcoin and then also for selling Bitcoin. So there's a difference, and I'm only interested in that difference for whatever reason, right? So I want to see how much Bitcoin do I actually own. That's a bit of a silly example, of course, but you get the idea. You can make this as complex as you really like. So this is the new wallet. So how can we actually map from our initial JSON to just this single class? And the way this is going to work is by providing our own deserializer. So let's start that. New wallet deserializer. And that's using the standard, I'm not even sure if std is standard, but I think it does mean standard. So now we say new wallet, and we have provide the type once more. So it's new wallet class Java. So let me close. I'm closing the JSON now, so we have more space here. And there is one function that I have to implement. And so you can see we get the parser, and I'm renaming stuff here because I think it's much nicer to read. That's rarely null, so I can just change that to be the non-nullable types. So, and with that in place, we get access to the entire JSON, and we can use it to access each individual property or object directly. And this is how we're going to do this. So we use the parser. Let's see, there's a codec that we're going to access, and it's read tree. I'm again using the JSON node, so I can work with it more comfortably. So this gives us access to the entire node as we've done initially. And now I can just use the root and say get wallet. So that's the first object. And then there's an array. There's an array of, of traits. I'm also using a JSON node here. And these are our traits, right? So this gives us access to the array of JSON nodes that represent the traits. So now we want to calculate or sum them up, like the purchases and the sales, and net them to see what the current amount of Bitcoin is that we have. So we can do this like this. I'm using traits. Then I filter the ones that have, I first have to access the type field, and I have to convert that to a text value and then equals by. So these are our purchases. This is what we bought. And now I want to just sum them up because there can be multiple. In my example, there's just one per type, one buy, one sell, but there can be multiple, of course. So I'm summing them up by, let me just think, get their amount. That's also a text value. And then here I can again use my extension function to as big decimal, that's mine. So, and that will sum up my purchases. And now we copy this and do pretty much the same for the sales, because it's not that much different, it's really just a cell. So this gives us the amount of purchases and the amount of sales all nicely summed up. So, and now we have to return the new wallet. And as you can see, there's really just the BTC, so I can just say return new wallet and then say purchases minus sales. So that's pretty much all. Let's go back to the test all the way up here. So this is really the interesting part. Now I'm no longer using the wallet wrapper, but I'm using the new wallet, which we have just created. Let's also rename that to wallet. Wallet and the BTC. So now we want to just run that code and see if that's the right amount of BTC that we would expect. It's not. So let's see. So it could map that fade for BTC, which is a non-nullable type. Oh yeah, of course. Now we have created the deserializer, but still JSON doesn't know what to do with it. You can also see that IntelliJ IDEA says that this is not used. And of course, that is something that we have to change. We have to use that class and provide the deserialize annotation again. This time we're using the using property and then reference the new wallet, the deserializer. So if we run this now, this should look hopefully much better. Yeah. So we can see this is the amount of Bitcoin that we have at this point after the trades have been netted. Now this works pretty nice, and with the deserializer we can do whatever we want because we have full access to the JSON tree. But one thing that's really a downside using this approach is if for whatever reason I want to use any other component in this deserializer, there's no way we could actually do this, right? Because this class is not, it's not managed by Spring, so we cannot use dependency injection, so we cannot easily get reference to other objects that we might need in the deserialization process, like formatters or other converters that we want to delegate to. So there's of course a better way, the Spring way. We can change this implementation quite quickly by providing the JSON format annotation. No, that's not true, it's the JSON component one, sorry, that's coming from Spring. So I can say this is a Spring component now, and then I have to use the JSON deserializer, this one, and that's no longer needed because it's probably clear from the type over here. So I did not change much, I just added this annotation, and I have to extend the JSON deserializer coming from Spring, and I didn't change the function itself. That still is the same. So, but now I can remove this annotation because right now this component will be picked up by Spring and registered automatically, so I don't have to do any work here. So if I just run the test again, that should unsurprisingly still show us the same, which is this. But now we have the full capabilities of Spring at our hands, so I can say, give me like the environment So if I want to access the environment or any other component right here, I can do this. Come on. Well, environment, Spring environment. Yeah, so I'm not even using it, but I can run the test again. And if it would fail to inject the dependency, there would be an error, but of course it does not fail. So we can see that everything is working pretty neatly. So this already wraps it up. Which of these approaches you use really depends on the use cases and your personal preference. For easy or simple structures coming from the APIs, I usually prefer the data classes directly because it's much easier to get into my head. But whenever I feel I want to provide specific mappings, as we have done here, or there's a deeply nested hierarchy, then I favor the custom deserializers because they give me much more control over the whole process. So yeah, I hope that was useful. If you're interested, let me know. We can also dive into the whole serialization process, which is more relevant if you're providing your own APIs. I suggest you continue with this video up here. Thanks for watching, and I'll see you on the next one.